Hello everyone. Welcome to the solution of LeetCode problem 876 named middle of the linked list. Here, in this problem, we are given a head of the single linked list. Now, we have to return the middle node of the linked list. If there are two middle nodes, we have to return the second one. Now, in the first example, we can see that we have 5 nodes, 1 to 5, and element 3 is the middle element. So we have to return it. Now, in the second example, we can see that there are two middle elements, which is 3 and 4. So we have to simply return 4. Now, I hope you understood the problem statement. Now let's move on to the algorithm. Now here, as we are given a single linked list, that means we have to at first understand the example here. The single linked list, in each of the node, it has two elements. One is the value and another is the memory address of the next node. And the initial node is connected to head, and the second value of the last node is connected to null, or it is set to null because it does not connect it with any other memory address. Now this make a single linked list connected. Now here we can see that there are two middle elements, which is 3 and 4. And if there are two middle elements, we have to simply consider the second one, which is 4. So here we have to simply return the linked list into this portion. So how can I do it? We can simply do by using the slow and first pointer mechanism. What is this? We will take two pointers. One is here and another is here. If we shift the left pointer by 1 unit, we have to shift the right pointer by 2 units. This is the basic understanding of slow and first pointer. Now, let's see how the slow and first pointer works here. Here, initially the slow will pointing to first element and the first is pointing to second element. Now, in the first iteration, the slow will be pointed or shifted rightward by 1 unit. So slow will be pointed here and the first will be pointed rightwards by 2 unit. So first will come here at first. After that, it will come here. So the first pointer is pointing to this element. Now again, slow pointer will be shifted 1 unit right, which is here. And first pointer will be shifted 2 unit right. One is here and another is here. So first pointer is pointing here. Now, again, we have to shift the slow pointer by 1 unit. So slow is pointing to this element 4. Now wait, for this element 6 or the first pointer, it does not have any other reference in the memory address because its memory address is set to null. That means we cannot expand the first pointer anymore. So here, what we have seen that so far our slow pointer is here and first pointer is here. And slow pointer is pointing to the element 4. So we have to simply ignore the first pointer and return the element which is into this portion or the portion of the slow pointer. And this is how the slow and first pointer will work in a linked list. Now we have to basically check two of the base case. If our head is null or our linked list has only one element, we have to simply return the head. And If our linked list contains two elements, now we have to return the second element. Otherwise, we have to simply run this process or this slow and first pointer simulation. And after that, we have to return the slow pointer value. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named middle mode, and which head is the parameter. Now, if head is null or head of next is null, that means it has either 0 element or 1 element in the linked list. We have to simply return head. Otherwise, if the linked list has 2 elements, we have to return the second element. Now, we have to take 2 pointers. One is slow and another is first. Slow is pointing to head, which is the first element, and first is pointing to head of next, which is the second element. And we are running this loop until the first pointer is not possible to shift right. Here, we are shifting the first pointer 1 unit, and if the first is still not equal to null, that means we can shift 1 unit rightwards once more. So here we have to again shift the first pointer. Finally, we have to shift the slow pointer. Finally, we have to return the slow pointer. And by this, we can find the middle element. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.